Hey, what's up everyone? In this video, we're going to go over the hardware for our thermostat video. If you guys haven't seen it yet, I would click the link below.
Alright, let's go through the hardware now. And we have the 8266 board with us. This is a development board. We have powered it through a USB bank here, powered off solar. We have the CP chip on this board for any serial communication that needs to happen with the 8266 chip. And that's how you burn your program onto the chip. So to start with the interface, we have three pins that we use for interface here. The D0 pin is used to interface with our relay board. This pin goes high or low, and the relay closes or opens based on that command. And we have D1 and D2, which is my I2C pins, which is my data access and clock signal to my display to run the wires from the board to my other boards that I have here. So this pin here is my relay output pin, and when this pin goes high, the output of the relay, if I'm using NO pin, that's normally open. When this pin goes high, the contact on this relay closes. Now just to look at the details of that board for a minute, we keep this aside. Let's take this board here. Now you see that we have three pins on this. We have VCC, N, and ground. Now my VCC here is 3.3 volts coming from my development board. And my N pin here is what is driving the output of this relay. So this chip over here is an opto isolator which separates any high voltage that's there on the other side of the board. Like I told you earlier, this board has three contacts, NC, a common, and NO. NC means it's a normally closed pin, so when there's no input going high, this pin would be always closed with the common. And NO is normally open, which stays open when this pin is low, and when we energize this pin here, this contact closes and the NC contact that we have opens. So this controls the heater in your house. Now let's go back. Now we look at the two wire interface pins. That's D1 and D2. So that is going on to my display board here. And we see that the display board has four pins. That's VCC, ground, SCL, and SDA. Now SCL stands for serial clock and SDA stands for serial data access. Now this is part of my I2C interface, and that helps provide the interface between my OLED display and my 8266 board. Now this is also chained with my MCP temperature sensor here. So this also has four pins. That's VDD, ground, serial clock, and SDA. It takes the same 3.3 volts power supply and provides the current room temperature to the development board through the two-wire interface that we have over here. And that's all, folks. Alright guys, now that we have gone through the details of the hardware, it's time to power it up. So I'll plug in the USB onto the battery bank that I have here. So you see the click, and it's trying to connect to the cloud, and it's connected. We're all set now. So it's time to talk to the hardware. So I have already logged into my Adafruit dashboard. So from here, I can trigger the heat switch, control the room temperature. It states that the current room temperature is at 81 degrees Fahrenheit. So let me trigger the heat switch so that you can hear the noise. You can see the heater's off. I can turn on the heater this way, and I can change the set temperature here. So you can see that the feed is updating the hardware, and it also displays the current temperature. So the next cool thing we will be showing you on the next video is sending a command to your hardware through Google Assistant. So to do that, I've named my Nest or the equivalent as a boiler. So here I issue a command, set boiler temperature to 95.
Boiler temperature set to 95.
So you see that we updated the temperature through Google Assistant. We'll be making a separate video on how to set this up, so look forward to it.